Hello and welcome back. We are going to finish off this week's conversation of advanced testing with a sort of quick video here discussing what it means for a test to be flaky or non-deterministic and then some strategies for dealing with it. I do say it's a quick video because it actually is sort of a quick topic, but I don't want that to undermine its importance because these kinds of tests happen all the time, and it's really important that we learn how to stabilize our testing suite, so that we have some more confidence and believe the credibility of our testing suite a little bit more. So what actually is a flaky test? Well, it's going to be a test that passes or fails seemingly unpredictably. We run our test suite over and over again, and sometimes the test passes and sometimes it fails, and sometimes it passes when it's in the first position but fails in the third, and then sometimes it passes in the third but it fails in the first, right? Even when our underlying code hasn't changed. So not even in scenarios where we made a tweak to our code and now suddenly it seems unrelated, but the test has failed. That's different. This is underlying code not changing and our test being flaky and not always passing. There are lots of different reasons why this might happen. And if it does happen, we're breaking confidence in our test suite. We can't actually trust that our test suite is going to give us the information we need to feel like we can release our code, right? This can waste time in our continuous integration and deployment pipelines. Those can be expensive, both time and financially, to run, to organize, to maintain. And if our tests can't be at least relied on from the code level, how can we expect this pipeline to be able to handle it? And it often leads us to just kind of rerun it instead of trying to figure out what's wrong and fix the issue. If we know it's flaky, we tell ourselves it's flaky and we go, well, let's just rerun it and see if it works the next time. And if it does, we are happy with that solution. But we haven't actually solved the problem. So we have a lot of really common sources of this flaky or non-deterministic behavior. Things like timing issues. So if a test needs some kind of a delay or an asynchronous result to come in, and for some reason it doesn't come in on time, our test will keep running without it and it will fail because we didn't get the data back in time. There are concurrency and race condition issues. So if we have threaded code, sometimes this can behave unpredictably, especially during tests if we haven't set up our synchronous time slots appropriately. There's this external dependency problem, as we previously talked about in the last video, where things like file systems and real networks and databases can introduce delays, which can then introduce failures. It also might mean that there's something going wrong on their end if it's an external dependency. There's this issue of date and time reliance. So some of the code that we write sometime really relies on actually today, right? So knowing what today's date is, or when I was working in payroll, there was a lot of date related information. So income tax date, start working date, end working date, fiscal year dates, effective dates, end of probation dates, right? There's retirement dates, current age, birthdays. So dates and time reliance can really cause some flaky behavior. And then, of course, randomness, right? The most common one that makes sense to us is this idea of randomness. So if we have math.random or the shuffling, some kind of non-deterministic behavior embedded in our code with probably good reason, we may end up in a situation where sometimes values pass and sometimes values fail, and we don't really know what's going on or why. We don't know which values are causing it to fail or why certain values might be causing it to fail. So what can we do to solve some of these problems? Let's figure out how we can be a little bit more stable. Now, instead of just, especially in our front end tests, we'll put the words sleep, and we'll try to basically force the thread to delay, right? We basically say, well, if I let it sit for 1 second, 2 seconds, 10 seconds, it doesn't feel like that long, to me as a developer, and it'll for sure be ready by then, right? That's not great for our tests because it's sort of introducing behavior that we wouldn't expect in real life. Instead, we could use a wait until, right? We can use event signals and we can use polling to sort of maintain consistency in our tests. So we can do a wait until, and then we can wait for that service to be ready, for the asynchronous call to, come in, or the flag that we're waiting for to come in. And then we have this duration of seconds variable as well that we can pass in. And this can tell us, how, like a minimum amount of wait time, or potentially, depending on the function, how frequently we should be polling to see if the service is ready for us. We can also inject randomness seeds for reproducibility. And this is so important and ties us right back in to dependency injection, right? So this way we can have a randomness seed. We can always seed our random at a given value and then inject our random object into the methods that need it. This will help us figure out why our test is failing, because if our test fails, it'll be reproducible. We can go, oh, we're failing for a specific reason. We can also reproduce the exact same seed strategy to ensure we have fixed the error from whatever is failing us. We can also be mocking our time instead of relying on actual real dates and times, because as we know, real time is unpredictable. Maybe we're deploying our code at 2 a.m. and maybe it's happening at 4 p.m. We don't want to rely on that as a reason for our test passing. So we can make a clock abstraction, make our own variable, our own interface, our own abstract class, whatever it is, make a test clock, and then we can actually set a fixed time of some kind and inject it into our service. So for randomness and for the date time stuff, basically whenever we have to rely on like Java or whatever language built in dependencies that might have some variability, we can inject it. Dependency injection is queen. And lastly here, let's replace those external services with fakes and mocks, right? Let's not rely on the real world network file systems or databases. We don't want to worry about that. As we previously said, if we're mocking these and faking them, we can more confidently say that we know what is failing, why it's failing, or more confidently say we know our tests are appropriately testing this chunk of code, and this chunk of code is not the problem. Stability effectively comes from control, right? If your tests depend on the environment, it's not really under test. We want to control that environment the best that we can. So how is it that we can actually start detecting some of these flaky tests? Well, there are some red flags or yellow flags that we can look for. Some of them are in CI, so in continuous integration, and these are things that we cover in software engineering too. But we can sort of tweak the wording of this so that it also makes sense for our course context. So if your tests are passing locally, but they fail on continuous integration, or maybe they fail when your teammate or tries to run your tests, or they fail when your instructor tries to run your tests, there's a good chance that something about the environment timing isn't working out right. Maybe we have resource conflicts. These are problems, and these are things that we can sort of use to understand we might be relying on our environment more than we should be. The next one here is tests fail, but then they pass on rerun. That's the most classic case, right? And there's a good chance that this may have something to do with a race condition, or maybe not waiting for the right delay. We see this crop up a lot when it comes to the UI. So when we're running our tests and we are running it through the UI, so like an end-to-end test, sometimes booting up the UI takes a longer time and tests don't always wait for them. And because of that, the test will fail because it can't find the button because it hasn't been rendered yet. But then the next time you run it, it happened to work a little bit faster, and this time it passes. So usually that's what's going on there. Lastly, we have that tests fail only when they're run within the suite of tests. So if you run a test individually and it passes, no problem, or you run it with a few select tests and it passes, but then you click the run complete test or the run all tests button and it fails, this is a problem. We should not be depending on when our test runs in terms of the order of the tests and being dependent on a different test running before us or a certain test not running until after us, right? That means that we're relying on a shared state, and that is a problem. Our tests should be isolated from each other. So like I said, in 4350, we'll see more of this, talking about using these continuous integration tools to help us find these flaky tests. But for right now, we do have access to logs, right? We can look for intermittent failures over time. We can use test flakiness detection plugins because they do exist in some places. A lot of those are continuous integration focused, but that doesn't mean we can't look into them and learn about them. And we can also check to see if failures correlate with things like network lag, right? So delays, resource contention, so race conditions, or parallelism, so synchronicity issues. So go and take a look at your own product's test suite. Go look through it, go see all your tests that you have, and see if you can isolate a flaky test. Do you have any flaky tests right now? And if so, how are we going to stabilize it? Do we need to do more dependency injection? Do we need to be doing a better job of separating our testing environments from one test to the next? Right? Go through your test suite and really see if you can find the tests that are causing those problems. Sometimes one of the best ways to start finding a flaky test is trying to run it on your machine and then trying to run it on a friend's machine or trying to run it on another team member's machine and seeing what happens. It should be as simple as plug and play, and all of your tests should run beautifully. And if they're not, if sometimes they work and sometimes they don't, it's a really good chance for you to sort of dig a little deeper and see if we can figure out how to stabilize our test suite. That's the last video in this advanced testing topic. Next week, we get to start talking about legacy code, which is a pretty interesting and fun topic, if I do say so myself. So I will see you all in the next series. Bye.